Hello everyone, and thank you for joining us. Today we are going to talk about the riddle of package managers that's solved by Conan. No, it's not Conan the Barbarian, it's a different froggy barbarian that's gonna help us to create a package manager for C and C++. So thank you for joining and let's start. So first, before we created Conan, when developing an application as a team, each developer should be able to build the entire application from the source. And of course, it needs to include its dependencies, and many large applications use multiple C and C++ open source projects, and unfortunately, they often have a unique and complicated build system. Right? Usually, each developers would love to use its own build system, and sometimes it could be very unique and very complicated. So whenever we need to share the code with the team, it sometimes could be really annoying and hard. So let's take this small team over here. So let's say that the guy with the green t-shirt from the left really love to work with CMake, while the other team here in the middle like to use B2, and the guy with the yellow hoodie really love to use Make. But the other guy from the right really loved to use Batel. And that's fine, but still, it could be really hard to manage all of these different complicated technologies and stuff. So in that case, Conan aims to reduce this burden on the developers. Once an open source project has been packaged with Conan, Conan users no longer need to interact with its build system directly and just use it. Instead, users can just install such project with the Conan install command, and Conan handle all the interactions with the build system in the background with a Conan recipe. So we create this amazing Conan chef, and we can easily use just the Conan install command. So for any given project, the recipe will capture the build instruction of that project for any platform with any configuration, and the team can work together with Conan. So Conan team and the community already created thousands of recipes for many of the most popular open source libraries, so you don't have to invent the wheel or just create everything from scratch. You already have some recipes that are available on the Conan Center, and we have more than 5,000 pull requests this year, and we're expecting for much more. So thanks everyone that's already support Conan, or if you want to hear more about this project, stay tuned and listen to this webinar. And again, thank you for joining today. My name is Batel and I'm a developer advocate at JFrog. Before that, I was part of the support team and the Hightot solution team, and before a few years I was an embedded engineer. And as you can see in the picture, I have an amazing doggy named Banjo. And before a few months, we just adopted another beautiful doggy named Soul. I'm a Marvel fan, so if you wanna talk to me with me about the movies, or just about some Funko Pops that I'm collecting, or anything else that's related to Marvel or DC, it's also nice. Feel free to reach out to me. I'm pretty available. You can find me on Twitter, LinkedIn, email me. And again, I'm always happy to help, so please do not hesitate to reach out if you need something. Before I start doing the examples, I want to provide a brief introduction to Conan. If you don't already know, Conan is a package manager for C and C++. It is open source and published with MIT license. It is multi-platform, meaning it can run on Linux, Windows, macOS, and anywhere else Python can run. Conan is designed to support all the popular build systems in C and C++, as well all custom build systems which are not uncommon in the enterprise environment. Conan is stable, which means that there are no breaking changes within major versions. That is to say that package built with any Conan 1.0 will continue to work with all future Conan 1.0 versions. And if there is a breaking change, it won't be until Conan 2.0 is released. Conan is also active. It has several full-time developers that working in JFrog, as well as a very active user community which submit dozens of pull requests each month. Also, our Slack channel has more than 1,200 members, and it's one of the most active channels for C++ community. And finally, the Conan team has created as multiple interactive self-paced training courses that you can easily find on the JFrog Academy. It's free, it's online, and it's a great training, so please check it out. I promise you're gonna like it. And you have all of the steps from the beginning to very complicated packages and your own Conan packages, and create some build configuration. So please check out the JFrog Academy and the Conan course. Now let's talk a bit about the architecture. The high-level design of Conan is fairly standard compared to other well-known package managers, such as NPM, PyPy, Maven, Yum, and much more. It featured the common concept of a local repository, which will be used for a local Conan operation, and remote repository for sharing packages with easy-to-use upload and download capabilities. There is also a centralized and moderate public repository with open source packages, which is known as the Conan Center, and we're gonna talk a bit about Conan Center and see how it will look like. And let's talk a bit about the architecture again and see what we have in this diagram. So we have Artifactory, which is a binary repository manager that can run self-managed, cloud, or an on-premise environment. We have our Conan client over here that can run on the developer machine or in the CI. And we have the Conan Center that contains the OSS packages. It's a cloud hosted, so you can reach out to it from anywhere, and it contains a lot of community contributions. So this is how it looks like, and we have three different repository types, and we will gonna to create the Artifactory server, which is free. It's a special version for Conan that you can easily try by this training. And then we're going to create some configuration with the Conan Center and see how it will look like. So while Conan is similar to other package managers in the high-level architecture, it's very unique, and it is package model. You can see here the string, the package /0.1 at user/channel, right? We have the package and we have the recipe that's running on the servers, and we have the client over here with the package binaries. So the string shown in the box is an example of the recipe reference. This is the most simple and logical identifier there is for a package in Conan. One of the unique things about the recipe reference is that it can represent any number of separate physical binaries with a unique build configuration. The package model in which a single identifier can representing any number of unique build configuration is one of the Conan's major innovation. So here's how Conan managed to do that. So you remember that we talked about Conan packages. We have the binaries, we have the recipe, we have the version over here. Now you can see that I have here some different numbers which are the package IDs, and I have different configuration in each one of them. Sometimes I change the build type to debug. Here I'm changing the shared to true. Sometimes I'm running with macOS, and of course I can change it according to my need. So in simple terms, Conan assigns the unique ID for each unique configuration. So you can see for each configuration I got a unique ID over here, right? And this unique ID is called package ID. The Conan uses that for various things through the build and packing process. So for example, the package ID is used for a fundamental part of the directory structure for storing Conan packages. So you can see here that I created a binary, which is part of the recipe. And now let's talk a bit about remote repositories. The client and the server also use the package ID as it matching the mechanism when uploading and downloading binaries. So for the most of the operation you do in Conan, you must specify a build configuration. With this configuration, the Conan clients will calculate the package IDs for each package and use them for various interaction with the server. So you can see here that I have the match package ID, and I have the options. I have whatever I need to build this specific package, and use them for various interaction, as I said. And also, once you have built and download a specific binary for a package on your local machine, that binary can be used across any number of projects. So on the same machine with the same configuration. So for example, in our team, we have few different developers that usually they are working with the same OS system, right? If it will be Linux or it will be Mac or whatever they are using. they're probably sharing the same OS system, so I can easily share this package across different machines and just reuse it. So in that case, there is no need to rebuild the same binary multiple times with the same configuration. I can just use the package on different location, and that's it. I don't need to create the wheel and just rebuild it again and again. Another major innovation of Conan is that it provides an abstraction layer over build system. So if you remember the first slide with the team with different configuration, I'll try to talk a bit more about it. So when developing an application in a team, it's a typical requirement that each of the developers should be able to build the entire application from source, including its dependencies, of course, right? We want to make sure that each of one of the developers can create everything from scratch and working on this code. So many C and C++ libraries and applications have multiple open source dependencies. And unfortunately, open source C and C++ dependencies often have a unique and complex build system, like we saw in the beginning. So this is a major burden for C and C++ developers who want to focus on the code and not build a system, right? We are developers, we hate to create our environment, we just want to write our code. We want to release it as soon as possible and just create another feature and not really spend our time by creating our build system and our environment. So Conan aims to reduce this burden on the developer. Once an open source project has been packed with Conan users no longer need to interact with its build system directly and just use it. So you can see here that we have our cmake command and I want to use the app, so I just use Conan install or whatever I need for this specific package. So users can just install such project with the Conan install command, and Conan handles all the interaction with the build system in the background. So I don't really care about the other interactions. I can just start my building and develop my code. Now I think it's a great time for a demo. So let's see how it will look like. So first thing that I open here is the Conan.io/training. So I have all of the training over here. So you can see that I have different directories with different projects here. And I can see the usage. So I just cloned this repository over here. You can see that I'm running the same. So I need to go to the Docker environment. I already download the Docker image, so it won't take too long, but if it's taking 2 or 3 minutes, that's totally fine. We have 2 images to build. So let's run the Docker compose. All right, let's see what do we have here. We have 2 different images. We have the Conan training and we have the Artifactory training. You can see that Artifactory is running on 8082, so let's go to 8082 here. Let's run it again, localhost 8082. All right, maybe it's still running. Let's give it a few minutes. It's probably still starting. Let's check the logs, Docker logs. All right, now it started, I hope. Okay, cool. So it's still running. You can see that Artifactory will install the services, the router, access frontend, and we'll get it in a few seconds. Awesome, so it's already run. The default credentials are admin passwords. So I'm just adding the credentials and I got my Artifactory community edition that's created especially for Conan users. So you can see that I can easily create the first repositories. Let's talk a bit about the local repository. You remember that I would like to contain the binaries that I'm creating. So let's go to Conan, let's call it Docker Conan local. And here you can see that I can define an include-exclude pattern. I can add a specific description and we have some advanced configuration over here. So let's save it and go to the next repo. So here is my remote. Let's create a remote one. So you can see I can easily use the Conan one or the generic one because this is a special edition for Conan users. But if you want the full other capabilities of Artifactory, just search for Artifactory in Google and you will get all of the information about it. So now it's pointing to a different repository. I would like to point to Conan.io, which is the Conan Center. Let's make sure that I have a connection. Okay, it's working, and we'll go to Conan.io in a few minutes and see what exactly we have there. So again, I can create some specific configuration for my developers, for my users, and add some include exclude patterns. Let's save it, and let's also create a virtual repo. So here's my Conan virtual repo. I can easily define the Conan repositories that I would like to have as part of this virtual. And here is the default deployment repository, which means where I would like to upload the artifacts that I just created whenever I'm pointing to one repository. So virtual repository provide me the ability to point into one repository and won't use few different repositories. So whenever I need a dependency, for example, I can take it from the few different remotes, few different locals, and so on. So I have everything in one single point that's called Conan. And of course, I can edit it in the future and add some more dependency repositories. Now let's talk a bit about Artifactory capabilities. So you can see here that under the administration tabs, I have the repository, I have identify and access, so I can easily configure and add more users to this environment. I can create a specific group with a specific permissions, and I can create an access token for my CI/CD. I can also import my users from the LDAP with the LDAP configuration. I can set up a proxy and do some monitoring about my storage, my system logs, and of course upload my artifacts to Artifactory. So once I will configure it through my Conan client, I can have all of the information over here. So let's see how it will look like. We will click on the set me up, so you can see in a few simple commands I can easily add my Artifactory as my remote, my Conan remote. I have to add my credentials here to get into my Artifactory, and then I can easily deploy and resolve with the simple Conan client command. So Conan upload and Conan install, like we're gonna do really soon. Alright, so let's get back here and go to the Conan training image that we have here. So we are inside the training. You can see that we have the same directories that we have inside the GitHub repository. So I'll go to the consumer. I created a small example so I can show you a bit more inside in the slides later on. So here, first of all, let's create some order and create a build directory. So here's my build directory. Now let's run Conan install. So as we saw inside Artifactory, the simple command to resolve the dependencies will be Conan install. So you can see that it's installing the dependencies that I need for this consumer project, and it's download them. So it may take a few minutes, and then we will see what we have inside this directory. And this is pretty fast, yeah. Let's take a second. All right, cool. So if I'll just scroll down and see what exactly I'm doing here, you can see that it's downloaded package from Conan Center. And I generated a text called Conan build info, CMake rated. So let's just open the Conan build info. So you can see that I have all of the information about my build, like the version, the users, the framework, everything I need to create this package. Now let's run CMake and make sure that we are able to create it. So CMake minus dcmake build type, and I hope I won't have any typo. Yeah, I have something. What I did, build dcmake. Oh yeah, in the beginning, let's use dash. I'm sorry. Okay, cool. So I compiled it with GCC that it's higher than 5. Check for the version, generating done, and I have something that creates inside my build. So let's see, what do I have here? I have my bin and the CMake files. Now let's run CMake to make sure that it's actually working. So I use CMake command just to build it. And we have the target timer, right? Something created under the bin/timer directory. So let's see, what do we have there? Awesome. We have a timer, we have a binary that can run, and we have our first example. Now let's go back to our training here and let's see what we can say about this file, where we found all of these includes and everything we used for this specific Conan package. So here you can see that we show all the places that dependencies are declared. So let's start from the left. We have the timer CPP that include POCO and timer H and regex HPP and all the dependencies declaration that we need for that. Next, let's go to the CMake list from the right. So you can see here that on the build system, the file include CMake and everything that I try to bold here. And finally, in the middle, you can see the Conan file that declared the name and the version of dependencies of the Boost and the POCO libraries, and we have some options for each dependencies. So for example, here you can see the Boost version and the POCO version and the options if you want to change it. And again, I'm really encourage you to check it out and test the Conan IO training. I promise you're gonna like it. You have different training with different compilers and build system. So just check it out. I promise it's worth it. Alright, now let's talk a bit about Conan cheat sheet. So I really like whenever I'm learning a new client or learning a new programming language to check the cheat sheet first of all. It contains the most useful commands. It's pretty clear. I really love that I can kind of figure it out what will be in this client or in this language whenever I'm reading the cheat sheet. So I highly recommend to check out the Conan cheat sheet. So as you can see here from the left, where it provides some commands how to show local clients configuration, how to display information from recipes or references, how to search for a package, and how to create your own package in three simple commands, how to upload a package like we saw on the set me up, and much more. So it's pretty simple. I think it's very useful. Whenever you have the cheat sheet, you can just take some notes and use it whenever you're just starting your journey with Conan. So I hope you're gonna like it. You can easily search for it on the JFrog documentation or in Conan documentation, or just search on Google Conan cheat sheet. I promise it will pop up. Now let's talk a bit about Conan 2.0. We're planning a new amazing version for Conan. So in July we announced the launch of the Conan 2.0 Tribe. We really appreciate the community and the tribe members. So if you want to take a part of it or just want to learn more about it, you can easily go to the github.com/ConanIT tribe. So let's see how it looks like. We can have it here. So you can see here all of the information on Conan 2.0, the proposal process, and the members. So you can easily add your comments and let us know what you think about it. And if you have anything to add, just share it with us. We really care about your feedback. And if you want to get some more resources, so let's try to conclude and make some order. We have the GitHub projects, we have our blogs, the documentation, Conan Center, and the JFrog Academy resources, and of course our Slack. So feel free to join and use all of these resources. I hope you like it, and thank you so much for joining. If you have any questions, please share it on the chat, and we are here for you guys. So thanks again for joining.